everyone, myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Now, in this video, let us learn about a number of problem execution using recursion, or let us learn about the recursive function concept in C language. Coming to recursion, what is recursion? When a called function in turn calls the same function or another function, then a process of chaining occurs and it is called recursion. So, the term recursion can be defined as the process of defining something in terms of itself. So, in simple words, it is a process in which the function calls itself directly or indirectly. Now, so based on the function is calling itself directly, we call it as direct recursion. If it is calling indirectly, that means the function A calls function B and function B calls function A, then there is a type of recursion that occurs. We call it as indirect recursion or mutual recursion. Every recursive solution has two major cases. One is called the base case and the other one is called the recursive case. So what is base case first? So base case is nothing but the problem is very simple enough so that it can be solved directly without making any further calls to the function itself. So that is the smallest part which can be solved independently of a complex problem. So that is till that time you have to call the function repeatedly until you reach to the base case. So base case is also known as the terminating case. Once the base case is solved, then it is also, you have to write down the terminating case for that. So what do you mean by the recursive case? Recursive case is nothing but in which first the problem is divided into simpler subproblems. Then second, the function calls itself but with subparts of the problem obtained in the first step. So this process will be repeated. In the third step, the result is obtained by combining the solution of the previous simpler parts. So first we will go for dividing the problem into subproblems and the process is repeatedly occurring. This is called the process of chaining. And at the end, we are combining the results of the previous subparts to get the output of the problem. Now, in this recursive process, you can see this example. The function is calling itself. This is called direct recursion. So, from the main function, first it is called and then after the function is executing, then the function within its body, it is calling itself repeatedly. So, this is called recursive in nature. Now, in any recursive process, it is important to have a termination condition or base condition to assure that the recursive process will end at some point of time. Otherwise, you will enter into infinite mode. So, it is very important to write the base condition or terminating condition properly in a recursive solution. So, in recursive program, the solution to the base case is provided and then the solution to the bigger problem is expressed in terms of a number of smaller problems. So, let us execute some programs and understand how recursion happens. Let us move on to our dep C++ compiler and execute some problems. So, the first problem is write a C program to print your name multiple times, suppose 3 times or 5 times using recursive function. So, how to display a name multiple times? So, the best approach is whenever you are doing the task repetitively, then you need recursion. Let us start with the header file #include stdio.h #include stdio.h header file and write down the structure of the C program. Main function int main return 0. Right. So here what we have to do, we have to simply call a function. Suppose f is a name is a function and I am passing 0 to that. Okay. Now here the function should be called how many times, that value I have to decide. So initially, I'm calling a function called, this is called function calling. So name function is called. Now what is the type of name function? This function takes nothing. So void name of the function is name, and it takes, we have passed one number that is called 0. Let us take a variable n to store that number. Okay. So int n is the variable where we are storing the number. Now we are writing the logic. We have to print our number 5 times. So what is our base condition? When number reaches to 5, we have to stop this process. So let us simply write return. Okay. When the number is less than 5, that means we have to print the name 5 times. So we'll write down a printf statement. Suppose you have written welcome to or welcome to C language. This is a string we want to print, and call the function again by changing the value of n. Initially n is 0. Now I will write n plus 1. So here every time the string will be printed and the function will be repeatedly called until you reach to the base condition. So save this program. Print name is the name of the program .c. Okay. Let us compile and run it. So you can see over here, welcome to C language, 5 times it is coming. So let us put a /n over here so that it will come in a new line, and again run the program. You can see here, welcome to C language is coming 5 times. This is called a simple recursive program. Now, which data structure is used in recursion? Because multiple times when the function is called, every time it pushes the function into the stack data structure. So the answer is stack data structure is used during recursion. Okay. Now let us go for another program to print the numbers 10 to 1. Print the numbers 10 to 1 using recursion. Now, first of all, we have to call the function, right? Hash include stdio.h int main and return 0. Structure of the C program. Now we will call a function. Let us call a function f, and we'll pass initially 1. Okay. Now our aim is to print the numbers from 10 to 1. So what type of function it is? It returns nothing. So void name of the function is f, and it receives a value n. Okay. Now, what is the base case or terminating case? We have to write first properly. So, when n reaches to 11, we have to stop our process. So, we'll write down if n is equal to 11, then we have to return from this function. Otherwise, we have to print the number from 10 to 1. It is not from 1 to 10, it is from 10 to 1. So, let us call the function. So, f is equal to, call the function f with the argument changed to n plus 1. And write down the print statement, printf %d/n, the value of n. So, it will go on calling the function up to n, that is up to 10 times. When n reaches to 11, it will return. While returning from the function call, then it will go on printing the value of n. So, when n becomes 11, it will return. It will return to where? Because from f10, the call was made to f11. So, it will come to the below function. So, there, what was the value of n? The value of n is 10. So, it will print 10. Then f of 10 was called from f of 9. Then the control will return to f of 9. So, there it will print the value of n, that is 9. Like that, in the return, the value of n will be displayed from 10 to 1. Now, let us save the program. So, print value.c. Okay. Now, run it. Yes, you can see the output over here. 10 to 1 is displayed successfully. So, this is the correct output of this program. So, this is the simple chaining process. What is going on during recursion, you can understand. Now, let us write down the program for factorial, for finding the factorial of a number. Factorial of a number using recursion. So how to find the factorial? Let us write hash include stdio.h int main and return 0. Right. So to do the factorial program, first of all, you have to read the value of a number. You have to read a number. So let us write int n, comma, to get the result, let us take a variable res, result. So read a number by writing printf, enter a number whose factorial you want to find out. So scanf %d, comma, ampersand n. After reading the number, call the function. The name of the function is fact and you have to pass the number, that is n. And the factorial result will be stored into your result variable. So if you want, you can take this as long integer also. So after getting the result, you have to display the result. So printf, the factorial of the number is %d, comma, the %ld because it is long integer, okay, and the variable is result. Now, so we have written the main function over here. Now let us go for writing the logic for factorial function. This function returns the integer. So int, name of the function is factorial and it takes one argument, so int m. What is the logic to compute the factorial? So in recursive program, first of all you have to write down the base case or terminating condition. So if the number becomes 0, then how much you have to return? You have to return 1. Okay. If the number is non-zero, then you have to compute the factorial. How to? So by writing simply return, calling the function again. So we'll write down return n into fact of n minus 1. So it is factorial.c, the program. Okay. So the function is calling itself multiple times here. Okay. And when till n becomes 0, if n becomes 0, then it is returning 1. So let us run the program. Enter a number. Suppose the number is 5. The factorial of 5 is 120. Yes, it is absolutely correct. Let us test with another test case. Suppose the number is your 7, then it is 5040. Yes. Similarly, 2-3 test cases you run. Suppose it is 3 factorial, then 6 and so on. So this is the program for factorial using recursion. Now let us move on to another problem. Write a program to print your name character by character using recursion. So you have to read a string or a name and you have to display the character by character, the name, okay, using recursive approach. So first write the main function, hash include stdio.h int main and return 0. Reading a string. How to read a string? Let us take character, okay, ARR of suppose some 20. Now take one integer variable for looping. Initially I is equal to 0. So first of all read a string. Printf, enter a string. Enter a string over here. Then use get string function to read the string. So get string of ARR. Then call a function print and pass the array ARR, comma, initial I value which is nothing but 0. And this function returns nothing. So we'll write down in the function definition we'll write down void name of the function is print, and it takes the array, so integer, sorry, it is character array, so character ARR of same size you will write down 20 comma int of I. So initial I value is equal to 0. Now when we should stop the process of printing the name character by character? When in the array the last character is always null character. So when we reach to the null character, so if ARR of I is not equals to null character, then we will repeat this process. When it reaches to null character, then automatically this program should stop. That is the terminating condition over here. So what you will do? We'll write down the printf function to print character by character. So percentile, suppose 4C, comma, ARR of I. So one character it will go on displaying. And we have to call the function because it is recursion. So print call ARR, comma, now we'll make it I plus 1. Okay. As we are not using any loop to print over here, so the substitute for a loop is or iteration is always recursion. So here we are calling the function by incrementing the I value. So I plus 1 it becomes now. Now let us save the program as print underscore name 1 dot c. Okay, let us check whether it is working or not. Yes. So it is asking me to enter a string. So let me write welcome is nothing but the string. So you can see over here, it is printing welcome string character by character. So this way, this program works like this. Let us try with another test case. Welcome to C language. Yes, it is printing character by character welcome to C language. So if you want, you can copy paste this output and keep it in your program. Okay, so this is another recursive program to print your name. Now let us move on to another program for finding the Fibonacci series. So the next program is C program to print or display the Fibonacci series. So hash include stdio.h int main and return 0. Structure of the main program first you should write, then followed by how to find out the Fibonacci series. So for that, let us take one integer variable I, comma, x, comma, n. Now first you have to read the value of n. Okay, for how many numbers you want to generate in the Fibonacci series. So n will decide. So enter the value of n first. Enter n, which indicates how many series will go up to how many terms. Now scanf percentile d, comma, ampersand n, number of terms you have read. Then you have to write down a function for I is equal to 0, I less than equals to n, and then I plus plus. Every time we'll call the function Fibo. Fibo is the function which will generate the Fibonacci next number by passing the value of I. So first time I is equal to 0. So what it returns? Then I becomes 1, 2, 3 and so on. And x is the return value from the series. Now every time we'll print the return value so that our series gets printed. So by writing percentile phi d, comma, x value. So every time the return value we are printing to print the x value. Let us save this program as fibo.c. Okay. So here Fibo function we have to write down. So the Fibo function returns the integer. So int Fibo is the name of the function. It takes one integer. So int n. Now, what is a Fibonacci series? In the Fibonacci series, the next term is always calculated by adding the previous two terms. So, that is the logic. So, how to check that? So, what we will write? We'll write down the logic. If n is equal to 0 or if n is equal to 1, then the return value is the same number itself. So, return n only. This is the base case or terminating case. So, if n is not 0 or 1, then how to generate the Fibonacci series? By calling the Fibo function for n minus 1 plus Fibo of n minus 2. This is the simplest logic for generating the Fibonacci series. That means here 2 times recursion happens. This is called double recursion. Okay, so linear recursion and this is called your binary recursion example. This example is called binary recursion. That means the same function is called twice by the function Fibo. Fibo of n minus 1 plus Fibo of n minus 2 we have done. Now let us save this program and run it. So enter the n value. Suppose I am giving n value is equal to 10. So you can see that it should print the series up to 10 terms. So it is printing 11 terms because we have written for I is equal to 0. So we can make it for I is equal to 1 up to n. So if you will make I is equal to 1 here, then we can simply check up to here, up to n is equal to 1. Let us check it. What is the problem here? So, okay, let us make it I is equal to 0 and it is up to less than n. So, if n is equal to 0 or 1, or if n less than is equal to 1, you can also write like this. If n less than is equal to 1, then return n. Okay, let us check now. Okay, read the value of n. Suppose n is equal to 10. Yes, so it is now coming up to 34, which is 10 Fibonacci numbers in the series. Similarly, once more test it with a bigger number. So let us take 15 numbers in the series. Yes, it is coming perfectly fine. So this is the logic for finding the Fibonacci series up to n terms. So this is the simplest way, and certain problems in C language are by default recursive in nature, like Factorial, Fibonacci series, these are by default recursive in nature. So you can write down always the recursive logic to solve those problems. Now let us go for another program without using recursion. Let us go for printing the Floyd's triangle. So the program is to print Floyd's triangle. Without using recursion. What is Floyd's triangle first? So for that, let me write. First number is 1, then 2, then it is 3, then 4, 5, 6, then 7, 8, 9, 10. So if you will print this kind of triangle, this is called Floyd's triangle. So how to do this simple program for Floyd's triangle? Let us write #include stdio.h int main and return 0. Okay. Now to print the Floyd's triangle, we will take one input variable n, comma looping variables I and j, and initially a is equal to 1. Now how many rows and columns you want in the Floyd triangle. First of all, you have to read that value. So enter number of rows and rows, at least rows of Floyd's triangle. Number of rows in the Floyd's triangle. Okay, so that value we will read it into the variable n. So scanf percentile d comma ampersand n. So after reading the number of rows in the Floyd triangle, let us write down the logic how to generate the series and how to display it in the triangle format. So for I is equal to 0, I less than is equal to n I plus plus. Again for j is equal to 1, j less than is equal to I j plus plus. Then we have to print the value of a first. So printf percentile d comma a value. What is the initial value of a? So 1 will be displayed, and then we'll do a plus plus. Okay, and it should look like a triangle. So after printing that row, the control should come to the next line. So printf /n. Now let us check whether this logic is working or not. Floyd's triangle .c. Enter the number of rows you want. Suppose n is equal to 5. Yes. So it is coming perfectly, but there should be proper spacing. So let us give some space over here in the code and let us run it. Again, n is equal to 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, up to 15. So yes, this is the logic for Floyd's triangle. So we have done this Floyd's triangle program. In this video, we have learned what is recursion and we have solved a number of problems using recursion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.